Hi everyone, it's lovely to see you and we really wish that you could be here. My name is Jo Harris and I'm the Operations Director at the Observatory Science Centre. Now, where's Sandra? Hang on. Oh, this social distancing lock is putting everything, oh, it's all over the place. Hello, I'm Sandra and I'm the Science Director here, and yes, as Jo said, we just want to introduce you to the festival and have some fun. Okay, I'm back. We're getting the hang of this now. We're keeping a social distance. We're doing absolutely great. We started the Astronomy Festival in 2005. Can you believe it? Now, you're astronomers. How many moons ago was that we started? I'm going to have to find an astronomer. Hang on, let me just go looking. Yeah, I'm back now. How many moons ago? I haven't got a clue, but it was 2005. Oh, can you remember, Jo? That was, it was a bit nervous anticipation. Was it going to be any good? Oh, I don't know. And it's just gone from strength to strength. And we're so frustrated that we can't see you, because you're not just our visitors, you've become our friends as well. So just sit back, relax and enjoy what we've got for you. So this is the 16th festival. Never mind how many moons, it's the 16th festival. We are celebrating our 25th anniversary as a charity looking after this incredible site. We need your help, we need your support, and we need to get this festival started. Are we ready? Yeah. Let's go.
So we're here in Dome F at the Observatory Science Centre. This is the story of the Royal Greenwich Observatory. And behind me is the 38-inch Congo Schmidt telescope. So, this is the largest and newest of the Herstmonceux telescopes. What happened, it was destined for the Belgian Congo. It was going to go to an observatory in Elizabethville, former Belgian Congo, but unfortunately civil war broke out there before it was actually installed. So it just languished for a little bit. Before 1972, the Royal Greenwich Observatory purchased it because they wanted a wide-angle camera on site. The telescope was actually built in 1960, and it was built to be very versatile. It was to be an ordinary reflecting telescope with prime, Cassegrain or Coude focus, or it could be a Schmidt camera, f3, which means it gives a wide-angle view and very sharp images. During the early 70s, lots of tests were being carried out with this telescope, and unfortunately they found the optics were flawed. There was slight warping in the glass, and they found stresses in the glass itself inside, and this was probably due to imperfect heating when the mirror was cast as a blank. So just to give a little bit of background on the blank, what do I mean? Well, that is the Pyrex that is cast before it's aluminized. So they grind it all down so that it's actually perfectly shaped for what they wanted to use the telescope for. The distortions only amounted to a few thousandths of a millimetre, but this unfortunately rendered it not suitable at all for astronomical research. They just couldn't use it, and there was no funding to remedy the situation, so unfortunately it has never ever been used in earnest or as serious astronomy work at all. The telescope was installed on a single pier equatorial mount. So equatorial means it works parallel to the Earth's axis of rotation, which is very good for photography work or taking astrophotography, astro images. It's got a 38-inch mirror at the very bottom of the telescope. At the very other end of the telescope, it has got a corrector plate, and then about halfway up, it's got a photographic plate. Now, the corrector plate gives it sharp images over this wide field, and that's where the Schmidt comes from, because this arrangement is actually called the Schmidt camera. So, hence, Congo Schmidt telescope. There isn't actually an awful lot more to say about this telescope because there was no research done, so I can't wax lyrical about what it found out about all sorts of different things, which is unfortunate. But what it does is make a fabulous backdrop to a fantastic exhibition about the story of the Royal Greenwich Observatory. We've also got in this exhibition a beautiful orrery, and the orrery works on 52 brass gears and shows the solar system and the movement of the planets and our moon around the sun. So it's well worth a look. So, the next time you're at Herstmonceux, come along to Dome F and you will see that wonderful telescope, the 38-inch Congo Schmidt. You'll also find the orrery, and you'll also find one or two other exhibitions about astronomy too. It's well worth a visit when you get here. So here we are at the Hewitt wide-field camera. It's a very odd looking telescope, I can tell you. And this was first designed by Joseph Hewitt in the 1950s, and it was intended to track Blue Streak missile. Blue Streak missile program was abandoned in the 1960s, but they decided to use the design of Joseph Hewitt and produced two cameras, and they were going to use them to track satellites for geodetic analysis. In 1967, the one in Worcestershire stayed there and the other one went to Edinburgh, and they were part of the Earth Satellite Research Unit. The two cameras were actually used to track satellites with a very high degree of accuracy. And by 1982, the Worcestershire place had to close and it was moved to Herstmonceux. In the same year, the camera that was in Edinburgh went over to Australia and was in Siding Springs Observatory. Both cameras still worked together until 1990, when Herstmonceux closed its doors. In Herstmonceux, one of the things that was quite interesting was it had reached quite a little bit of publicity when it tracked Cosmos 1402, when it had to forced re-entry into the Earth's atmosphere. Now, Cosmos 1402 was a Russian spy satellite. This particular camera was the last camera to take any photographs here at Herstmonceux before, unfortunately, the Royal Greenwich Observatory at Herstmonceux moved to Cambridge. What's really interesting, I've been in contact with the Tamworth Regional Astronomy Club in Australia, and they actually inherited the telescope from Siding Springs in 2016, and they've now actually got it to work, so there may be hope for this one yet. So just to compare, this is a modern 16-inch Meade telescope, which sits in this lovely dome, and on clear nights we actually use this on stargazing evenings. So this is a comparison really between old and new, and you've got the 34-inch Hewitt by the side of a 16-inch modern Meade telescope. I hope you've enjoyed your brief introduction to the Hewitt camera and introducing the Meade telescope that we actually use on stargazing evenings. This is Dome C, so if you are able to visit us, this is where you need to come to see these lovely telescopes. The annual Astronomy Festival is our biggest fundraising event of the year. We don't get any external funding for the upkeep of our telescopes and domes, and we really want to keep them in the condition that they really need to be in for you to look through and come and really enjoy the night sky with us. So if you are able to help us and pledge a donation, then there is a crowdfunder link on our website. There is also a donation button on each of the pages on the website as well. Thank you very, very much, and we'd be ever so grateful if you can donate.
A couple of months ago, our skies were graced with one of the brightest and best comets to be seen for some time, Comet Neowise. And from this site, we were able to get some excellent views of Neowise. Now, a comet is an icy messenger that comes to us from the distant reaches of space. And it will travel around the solar system and may well pass many of our planets. So we're going to use that now as an excuse to hitch a ride on Neowise and take a quick tour of our solar system. So we can look back on our home, the Earth. And we may call it the Earth, but it is defined by water. Water upon the surface of the Earth is what makes life as we know it possible. And a great question we've got is, where did that water come from? One possibility is that the water was delivered to us on the Earth by comets such as the one upon which we ride now. But we'll carry on away from the Earth and head towards Venus, the nearest of the planets to us. In so many ways like the Earth, and named for the goddess of beauty. But whilst from the Earth we can see it's covered in cloud, when you approach it, this is far from beautiful. A planet where the temperatures reach 500 centigrade, the rains are sulfuric acid, the mountains are decorated with a frost made of metal, the pressures are crushing, and volcanoes spew across the surface. This is a terrible place for anybody to visit. But even here, we could visit this. Spacecraft that have landed on Venus rarely last more than a couple of hours. But it is possible to fly craft through the skies of Venus. The Vega spacecraft flew for days, nearly a week, through the skies of Venus. So, you never know, maybe we could visit. Just don't set your foot on the ground. And on to Mercury, the closest of the planets to the Sun. So close that the temperature upon the surface rises to 400 centigrade. This is baked, furiously baked under the sunlight. But it spins incredibly slowly, so slowly that its nights are so long that in the night the temperature can fall below minus 100 centigrade. It spins so slowly that one day upon the surface of Mercury lasts for 2 of Mercury's years. And even here we have discovered water. The craters at the poles of Mercury are so deep that they never see sunlight, and their temperature never rises above freezing. And we have discovered evidence of frozen water, ice, on the surface of Mercury. But this close to the Sun, our cometary lift is starting to evaporate and boil away. So we'll turn away from the Sun and follow our comet as it heads out past the Earth and out towards Mars. Mars, a dry and barren world. But it was not always so dry and barren. There are vast river valleys and great lakes upon Mars. If we could wind the clock back far enough, we would find that Mars is a warm and watery world. There are vast canyons on Mars, larger than the Grand Canyon. These would have formed huge river valleys, pouring out into a great northern sea. That water, though, has long since evaporated, and now Mars is dry, barren. Well, the spacecraft visited it, and some of them have found some water, maybe enough for us to use in future, but largely it is a desert world. And on to the largest of the planets, Jupiter, the king of the gods. Jupiter, with its vast red spot, Jupiter with great storms and cloud patterns stretching around its surface. Jupiter, a gas giant. There is no surface. If you were to try to land on Jupiter, you would sink through the clouds and be crushed by the weight of clouds alone. There might be a surface somewhere way down in that depth. We honestly don't know for certain. It might somewhere deep down there have a surface rocky like the Earth's. It could be some bizarre and exotic material like metallic hydrogen. But certainly if we're going to come and visit here, we're not going to land on Jupiter itself. If we did want to stop though, it's got plenty of moons we could stop off at. There are lots of very small moons. We won't worry about those. But it's got 4 big moons, the Galilean satellites. These are moons that are the size of planets, moons that are larger than the planet Mercury. There is Io, close to Jupiter, heated by the gravity and the tidal effects until the whole surface is one rolling, boiling volcano covered in sulphur, a very vision of hell itself. Dante would be proud. But let's have a look at this. It's Europa, further out. It's cold, it's frozen, and that frozen surface is water ice. And this is fascinating because deep beneath that ice is an ocean. The largest ocean of the solar system is not upon the Earth. It is buried beneath the surface of the moon Europa. This might well be the best place in the solar system to look for life. And on to Saturn. Famous, of course, for its rings. Another gas giant planet, very similar in that respect to Jupiter. Now let's have a look at some of its moons. There is Titan, one of the largest moons in the solar system. And it's got a big, thick atmosphere. And just like the moons around Jupiter, we can land here. We have landed here. A little robot called Huygens landed in 2005. And it was able to see that the surface of Titan has rivers and lakes. It has clouds, it has rain made of methane. The temperatures here are so low that it rains methane and the rocks are made of ice. So we have a lake of methane sitting upon rocks made of ice. And below the rocks made of ice, and there's a good reason to believe, there may be more lakes of water. Even out here we can find water. But a better example of a cool moon is Enceladus. It's quite a small moon. But its surface, another frozen surface of water ice. And we can see geysers erupting, blasting crystal jets of ice into space. And they are replenishing the rings of Saturn. Saturn is refurbishing its own ring system by tearing apart its own moons. And as we head out past the gas giants, we carry on and past the ice giants, Uranus and Neptune. And Uranus and Neptune have been rarely visited and are barely known. Only one spacecraft has visited them. We might be able to study them with telescopes like this, but a single spacecraft, Voyager 2, has visited them way back in the late 1980s. So I'm afraid we must leave them as mysteries to be revisited. But we will carry on for just a little bit further. And as we carry on out, we go past Voyager 2. Voyager 2 is one of the most distant spacecraft we have ever built. It has travelled so far from the Sun that it will never return. It is our first emissary to the stars, and it will travel forever. Our comet will not go to stars, it will come back. But our comet, Neowise, will take 7,000 years before it returns to be seen again. So we're going to leave Neowise now and head back to the Earth.
The annual Astronomy Festival is our biggest fundraising event of the year. We don't get any external funding for the upkeep of our telescopes and domes, and we really want to keep them in the condition that they really need to be in for you to look through and come and really enjoy the night sky with us. So if you are able to help us and pledge a donation, then there is a crowdfunder link on our website. There is also a donation button on each of the pages on the website as well. Thank you very, very much, and we'd be ever so grateful if you can donate.